Hello my dear students, welcome back in the lecture series on project management techniques. In this video lecture we would discuss about the project evaluation review technique, and we would know how to determine the expected time of the activities, the variances in the activity times, and the critical path for a given project. As we know that there are two types of techniques that can be used for the project management, and one is the network analysis technique. A network basically is a graphic representation or depiction of various activities that are conducted or performed to complete a given project. And there are two types of network analysis techniques. These are project evaluation and review technique and critical path method. In earlier videos of this lecture series, we have discussed about the critical path method. In this video, we will discuss about the project evaluation and review technique. Before that, we must be clear about the applicability of PERT and CPM techniques. What are the situations or conditions in which CPM or PERT techniques are applied? As we know that to apply critical path method, we assume that certain times or certain information is with the decision maker, such as we know the completion time of the whole project, we know the completion times of the activities, and know the amount of resources required to complete the different activities. So the situation is quite certain when we apply critical path method. But when situation is not certain, or we are operating under conditions of uncertainty, then we apply project evaluation and review technique for efficient project management. PERT is applicable in situations in which the completion time of whole project is not certain, completion times of different activities are also not certain, and amount of resources required to complete different activities is not known to the decision maker. So we can say that PERT is quite probabilistic in nature, and we apply PERT technique when we are operating under situations of uncertainty. In other words, we can say that in situations in which we don't know the starting time, the finishing time, or latest start or latest finish of different activities, and we are not certain about scheduling times of various activities of the project. So under conditions of certainty, the scheduling times of different activities or starting or finishing times of different activities are assumed to be known and constant. But in situations under uncertainty, this assumption does not work, and scheduling times of different activities are assumed to be unknown. In such situations, the decision maker estimates the completion times of different activities in a given project, and generally he or she uses 3 time estimates for completion of any particular activity in a given project. These 3 time estimates are discussed one by one as follows. The first one is the optimistic time. As the name is suggesting, it represents the minimum possible time that any activity may take for its completion. Basically, it is the shortest possible time duration required to complete an activity of a project in hand. It represents an ideal estimate of the activity. The chances that any activity completes or get completed in optimistic time duration are very less, because it is not a common phenomena when it comes about the project management. So the chances are very less, or probability is very less that any activity gets completed in optimistic time duration. The second one is pessimistic time. that is the second estimate for completion of an activity in a given project. It represents the maximum possible time that any activity may take for its completion. It is the longest possible time duration required to complete an activity of a given project. So unlike optimistic time, pessimistic time denotes or depicts the maximum possible time that is required to complete an activity. So these two time estimates represent the two extreme points when it comes to the decision making in project management. So there should be a midway between optimistic time and pessimistic time, that is known as most likely time. So it is neither pessimistic nor optimistic estimate of time. Instead, it represents the time duration in which any activity gets completed most of the times if repeated several times. So it is the model time required for completion of an activity. So most likely time denotes the normal course of action. If any activity is repeated several times, it would get completed in most likely time duration. So it has the higher probability or higher chances of happening. These three estimates of activity times generally follow the beta distribution. As you can see in this graph, the y-axis represents the probability and x-axis represents the time duration of the activities. On the left side, it is the optimistic time, which has very less probability. On the rightmost side, again it is the pessimistic time, which again represents a very low probability of happening. But the mid area of this graph represents the model or most likely time of happening of an activity. So basically it follows the beta distribution. If we have these three time estimates for completion of an activity, in next step we need to calculate the single expected time for the given activity. And what is the formula of calculating the single expected time? It is denoted as follows. This is the formula of calculating single expected time for an activity, where TEI represents the expected time of the ith activity, like it can be first, second or third activity. If you are calculating the single expected time for an activity, then it would be the formula where TEI represents the expected time of the ith activity, E represents the expected time, TA represents the optimistic time of the ith activity, this one, TB represents the pessimistic time of the activity or the highest time for completion of any activity, and TM denotes the model or most likely time of the ith activity. So in this way we can calculate the single expected time for an activity. And in this formula we have used, or we have given, weightage to different estimated times for the activity, and we have given the highest weightage to the model time or the most likely time, because it has the highest probability in a normal course of action. That's why we have given the highest weightage to this time or to this estimate of the time. So single expected time is the first parameter for evaluating any given project, and the second parameter is the standard deviation, which denotes the deviations in the expected times of different activities, and it is calculated by using this formula, that is TB minus TA divided by 6, where TB represents the pessimistic time of the activity and TA represents the optimistic time of the activity. By using this formula, we can calculate variance for a particular activity by using this formula, where sigma I denotes the standard deviation of the completion time of an activity, and sigma square denotes the variance of the completion time of an activity. So with these formulas, we can analyze a given network. After calculating single expected times and standard deviations for different activities, we need to calculate the expected time for different paths in a network. So the expected time for a particular path is calculated by using this formula, where TE denotes the expected time of the path and TE1 represents the expected time of the activity 1 of the path, and TEK denotes the expected time of the activity K of the path. Similarly, TE2 represents the expected time of the activity 2, and TE3 represents the expected time of the activity 3, and so on up to kth activity. So we have to sum up the expected times of different activities to calculate the expected time of a given path. In this sequence, we need to calculate the expected variance for the given path. Again, we need to calculate the sum of the variance of different activities that constitute a given path. Sigma 1 square denotes the variance of activity 1, sigma 2 square denotes the variance of the activity 2, similarly sigma 3 denotes the variance of the activity 3, and sigma square k denotes the variance of activity k. So by using this formula, we can calculate expected time for a path and expected variance for a given path. So with this information, now we would discuss how to calculate the project duration. And to calculate the project duration, we need to find the critical path of the network. The length of the critical path would represent the time duration of the whole project. So basically, we need to find the critical path to find the duration of whole project. Now we would understand all these aspects and parameters of project with the help of an illustration. The information is given in this table regarding a project in which there are 9 activities that are named as A, B, C, D, E, F, G, H, I, and their respective nodes are given in this table. Further, the different time estimates are given for each activity. Like for activity A, the optimistic time is 4, the pessimistic time is 8, and the model or most likely time is 6. And in a similar manner, the information is given about different activities. So in process of finding the critical path for this project, first of all, we need to draw the network with the given information, with the help of given information in this table. And for that purpose, we need to start with the initial activity of the project, that is activity A. So activity A would start from node 1 of the network. So first of all, we need to draw the node 1 and represent the activity A like this. Here 1 and 2 denotes the nodes of the activity. 1 is the starting point of activity A and 2 is the ending point of activity A. After that, we need to draw the second activity, that is activity B, of which starting point is node 2 and the ending point is node 3. So in this way we can draw the activity B. After that, we would draw the activity C, of which the starting point is 2 node 2 and the ending point is node 4. The activity activity D is starting from node 3 and ending or terminating at node 6. So we can draw it like this. Activity E lies between node 3 and 5. Activity F is between node 4 and 6. Activity G is starting from node 5 and ending at node 7. Further, activity H is starting from node 6 and ending at node 7. And in the end, the activity I, which is starting from node 7 and ending at node 8. So in this way, in first step, we have drawn all the activities that are given in this particular project. Remember, while drawing the network, we must follow all the rules that we have discussed in the first lecture of this lecture series, and we should keep in mind the logical sequence of all the activities while drawing this network. The next step in this process is to calculate the single estimate for each activity or single estimated time for each activity, and we will do it by applying this formula. So in this diagram we have shown the optimistic, pessimistic and most likely time for each activity with their respective names. Like for activity A, the optimistic time is 4, pessimistic time is 8 and the most likely time is 6. So, and in a similar manner for other activities, we have given the optimistic, pessimistic and most likely time in same sequence. So first letter or first number denotes the optimistic time for that particular activity, second number denotes the pessimistic time, and third number denotes the most likely time of completion for that particular activity. So in this way we have denoted these time estimates for each activity in this diagram. After that, we need to calculate the single estimate for each activity by using this formula. So let's start with activity A. So by replacing all the values in this formula, TA is 4, TB is 8 and TM is 6. So putting these values in this formula, we would get the single expected time, that is equal to 6 days. Similarly for activity B, it would be 8. By putting all these values in this formula, we would get 8. For activity C, it would be 8 days. For activity D, by applying this formula, the value would be equal to 20. For activity E, it would be 18. For activity F, it is 10. For activity G, it is 8. For activity H, it is 2. And for activity I, it would be equal to 7. So by using this formula, we can calculate the single expected time for each activity. So in step 1, we have drawn the network for the given activities. In step 2, we have calculated the single expected time for each activity. So now in step 3, so in third step, we need to calculate the completion time for different paths in this network. As we can see that there are different paths in this network. So we need to calculate their completion time. For the first path, that is named as ACFHI, which consists these activities. It starts from here, that is activity A, activity C, activity F, activity H and activity I. So it is one of the paths of this network which consists 5 activities. So the completion time for this part would be equal to the sum of the estimated times of different activities that are consisted in this path. That would be equal to 6 plus 8. 6 is the estimated time of activity A. 8 is the estimated time for activity C. 10 is estimated time for activity F, and 2 is for H, and 7 is estimated or single expected time for activity I is 7. So the sum total of these activities would be equal to 33. So the completion time for this path would be equal to 33 days. Second path is ABEGI. That is activity A, activity B, activity E, activity G, and activity I. So the sum total of this path, or the completion time for this path, would be equal to 47 hours. And for the third path, that is ABDH, A, B, D, H, and I, the completion time is 43 hours. So which one of these is the critical path for this project? The path which has the highest completion time would be known as the critical path for this particular project, and the highest time or largest time completion time for the in this case is 47 days. So the path that is starting with activity A, going to activity B, then to activity E, activity G, and activity I is the critical path for this project, and the activities making this path would be known as the critical activities of the project. So these activities cannot be delayed, otherwise the whole project would be delayed. So the management would focus on these critical activities and on this critical path, and would try its best to get it completed in the expected time. So in this way we can find the critical path in case of project evaluation, review technique, or network analysis. In a similar way, we can calculate the standard deviation and the variance for each activity. In case when there are more than one critical path in a given project, then we would select the critical path with highest variance. So if there are two critical paths in a given project, then we would select the one with highest variance. So in this way, we can find the critical path for a given project by using the PERT technique. First of all, draw the network, then calculate the single estimated time for each activity. In the next step, find the critical path of the project, and on the basis of that, calculate the expected time or time required to complete a given project by finding the critical path, and then calculate the variance of the critical path. So this information would help the management in efficient decision making. Thank you.